Okay, welcome to chapter 1. This will be a quick video, the start of this, because it's mostly lab techniques and safety, which I'm going to cover mostly in class, just to make sure we get it really uh, thoroughly covered. Now you can see the topics here for chapter 1. The first half is lab safety equipment and techniques. I will do that in one video. Part 2 is types of matter, physical versus chemical changes, and phase changes, so that will be in a later video. To start here, so welcome to chemistry. We'll talk more about what chemistry is in class. I do go through some of these slides in class as well. These are just supplemental videos. So we'll do some of these demos, some of these we'll definitely be doing labs in this class, so we'll pass through this pretty quick. As always, there's going to be chemistry jokes, so what's the difference between chemistry and cooking? You can pause if you want to figure it out. In chemistry, you never lick the spoon. So your first safety joke, or your first joke is a safety joke. So let's get right into lab safety here. You can see we'll get to these symbols here in a second. Lab safety, the number one rule is common sense. Make sure that you're behaving yourself, following instructions, and just not goofing around. That'll cover most of the lab safety that you need to be aware of. Other than that, always wear your goggles. Sometimes we'll be wearing gloves if we're using strong enough acids. And then we have aprons that you'll wear as well. Here it's kind of a blurry picture. This is from before I was ever teaching, actually before I even graduated high school. This is a picture of an acid burn from a student. Mr. Crone knows the story behind that, so you can always ask him that story. So the safety symbols. As you can see here, these are the old symbols. I got old symbols over here. Know these because we do have them on our labs. Every lab we put all the safety symbols that you need to be aware of. Are we using, we won't be using any biological hazards, but if we were, we'd have that on the lab. You'll see this symbol a lot, poison safety, eye safety on the labs, fire safety, clothing protection safety. So just know what these are. These will be tested on as well. So I will let you study these on your own. This is the hazmat diamond. This is something else you'll come across frequently. It's got four diamonds within the one diamond. The blue represents the health hazard. Red is fire hazard. Yellow is reactivity. The higher the number, the worse it is. So a health hazard of 4 means it's extremely deadly. 0 means that it's normal. So water would be like a 0. Your typical poisons would be a 4. Things that take a small amount to kill you would be a 4. If it lights on fire easy, or as you can see here, if it will ignite below 73 degrees Fahrenheit, then it's listed as a 4. If it doesn't burn, it's a 0. Reactivity, I can let you read those on your own as well. Okay, now these are the new symbols. These are on every bottle that we have in our storage room. We had to update these a few years ago. These are a little less intuitive sometimes. Most of them are pretty easy to see, but know these as well. So you got exploding bomb, corrosion. Now there's two symbols that look like a flame. There's a normal flame that you'll see in a second, then there's one that has an O. So O means it's an oxidizing gas, oxidizing liquid, oxidizing solid. We'll explain what oxidizing means more later in the year. But that is not necessarily the same thing as just a flame. Flame means it's flammable. The flame with an O means it's an oxidizer. Okay, you got gas cylinder, environment, toxic. So this is another one that's a little bit confusing, or you could get mixed up with another one. You got toxic is the skull and crossbones, and where is it here? We've got health hazard. They are slightly different. So if something would give you cancer, it might not kill you immediately, but over time, exposure to it could lead to health complications down the road. That would be health hazard. If it will immediately kill you, it's acute toxicity, like if you inhale a little bit of the dust, or if you eat it, or it gets somehow into your body, it will kill you very quickly, versus it may cause complications down the road. You'll see this symbol, the exclamation mark, on pretty much everything. It means irritant, so just be careful, don't get on your skin. Wash it off if you do. It's generally like a mildly hazardous chemical, but it's literally on every bottle, so just be aware that you'll see this one a lot. Okay, now into the lab techniques. And again, that's a brief introduction to lab safety. We'll get into it more in class. So reading the meniscus, two things you need to know. Read it at eye level. Read it from the bottom of the curve. So what we mean by bottom of the curve, and what we mean by the meniscus, I should say, whenever you have a water in a glass container, the water is attracted to the glass, so it'll try to climb up the edge of the glass, and it gives you this curved surface. We call this curved surface the meniscus. It's spelt right here. Now, to read this, you always read it at the bottom. So the lowest point of the curve, where is that relative to the graduated marks on the container? So if I were reading this, I need to read it at the bottom of the curve, and it needs to be at eye level. So make sure you get down at the same level as the meniscus and read it straight across. Don't read it from above. Read it from above. Don't read it from below, because you'll get high or low readings. And this will be on the test. So you need to know these two things. Read it at eye level, read it from the bottom of the curve. The other thing is you should always make sure that you set your container on a level surface. That's kind of a third one that's not mentioned as much. Okay, so to practice, we've got a graduate cylinder here. Pause the video, and when you think you got it, hit play. So again, here's the meniscus right here. I would read it straight across, and I'm drawing here with a new device, so it might not be the neatest. So I'd read it straight across at the bottom of the curve. Now we've got this line is 15, this is 20, so it goes 15, 16, 17, 18, 19, 20. You should always make sure that you check what each mark stands for. Sometimes they go by 2, sometimes they go by 0.5, sometimes they go by 1. This one goes by 1s. It looks like it's right on 16, 17, 18. So I would say 18, and these are almost always in milliliters. So I would read this one as 18 milliliters. Next chapter we'll actually talk about where you round your answers to. In this case we would actually round it to 18.0 milliliters, but we won't get quite that in depth yet. Again, pause the video, give it a shot on your own, then I'll go here. Okay, I'm back. So it looks like it's just under that line, the bottom of the meniscus. So this line is 50, this line is 60. Looks like there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 markings, so each one represents 1 again. So we got 50, 51, 52, and 53. So it's between 52 and 53. So I know it's 52 point something. I'm just going to estimate it's about 52.8 milliliters. If you had the 52.7 or 52.9, call it good enough. A couple more practices here. Again, keep pausing. Check it yourself, and here we go. So it looks like it skims about right there. I think my line goes down a little bit. So again, check. This line represents 6. This line represents 8. So this line represents 7. It's halfway in between. Now to go from 6 to 7, there's 1, 2, 3, 4, 5 lines. So there's, for every 1 milliliter, there's 5 lines. So each line represents 1/5 of a milliliter, or 0.2 milliliters. So that means that this is 6.2 right here. 6.2, 6.4, 6.6, 6.8 milliliters. So it's between 6.6, 6.8. And it looks like it's about on the 6.6, and when we get to significant figures, you'll see that you'll probably have to round that to 6.6. One more try. Give this one a shot on your own here. Pause it. Now let's quit go. We'll go a little quicker. And I know my lines aren't perfectly straight. It's hard to draw straight lines with this. Couple things here. This line represents 40. This one that goes all the way across. The 40 is right above that line. And then we got 41 that looks like it's down there. So this is actually 40.5. 40.5. And notice 40, 41, it goes, the numbers get bigger going down, which is opposite from graduated cylinders. That's because this is a burette. We'll get into what a burette is in class. You actually measure how much you pour out of your burette instead of how much you put into it. So that's why the numbers are opposite. So it's between 40 and 40.1. So I'd say it's about 40.05 milliliters for that one. And again, if you have questions on these, bring them to class. Okay, filtering. Whenever you filter something, I'll actually go to the next slide. You set up a funnel with a filter paper. You've got a solid that's mixed with a liquid. You pour it out, you want the solids to get stuck and you want the liquids to go through. Now, whatever goes through the filter paper, so anything that makes it through the filter paper, we call a filtrate. Whatever gets stuck in the filter paper, we call the residue. So the official definitions are here. You can write these down if you would like in your note outline, but we'll keep going. Now there's 3 ways to accurately measure a liquid. A beaker and an Erlenmeyer flask are not something you measure liquid with. So we've got an Erlenmeyer flask down here. This is not something you measure liquids with. It has markings on the side, but they're a general guideline of how much you have in there. They are not at all intended to be accurate enough to measure with. So the 3 things, we've got a pipette. Pipette's on top here, graduated cylinder, and then I mentioned the burette just a minute ago. It is right there. And there we go. We've got our graduated cylinder that has graduated. Definitions, I'll let you write these down. We'll cover these in class. We talked about the meniscus already. Decanting, ask me to demo that one in class if I forget. And precipitate, we will actually see right here in our little picture. It's a solid that forms out of solution. We'll talk about those over and over, so we'll keep going. These are the techniques that you need to know. In class, we'll cover them in the intro lab and in class. So that is where I will end this video.